All right, in our next video, I am now on page 42, and so what we're going to talk about is what if our problem's in standard form, but it's not factorable. So while you're on page 42, I'm just going to jump back to a previous page and just remind you of some things that we've talked about. So we first looked at if it's in factored form, we can use the zero product property. And then what we did is we did standard form, and we got it into factored form by factoring and then use that zero product property. But in one of the last problems, we had something that wasn't factorable. And so this is our plan, our backup plan when it isn't factorable. And it's called the quadratic formula. So the first thing is this only works on a quadratic. So you have to have that squared there in order for this to work. Any other exponent, this will not work. And the idea of the problem, right, is you've got this formula. And it's based off of standard form. It's based off of, I'll fill in a couple things here, ax squared plus bx plus c equals 0. So remember, standard form, it has to be the x squared, then the x, then the constant, and it has to equal 0 in order for any of this to work. And then what happens is the quadratic formula goes like this. So the only parts we need are the numbers in front of the x squared, the number in front of the x, and the c. X will never get put into this. And they put the symbols to hopefully make it look more familiar. But just remember that a is the number in front of x squared, b is the number in front of x, or the coefficients I should say, and c is the constant at the end. So the formula goes like this, and if you were here we would make you sing a song, but this is a formula you gotta know. So it goes x equals opposite, looks like a negative sign, of b, and then I'll do plus or minus, and then I'm going to have a square root. And so if you remember, there was a time in a previous assignment where I didn't want you to write like positive 5 and negative 5. I wanted you to write a positive, negative, and then 1, 5. That's where this comes into place. So it'll be opposite of b plus or minus square root, big square root, and then in that square root you're going to take b and square it, and then you're going to subtract 4 times the rectangle, which is a, times the heart, which is c, and then all of it, not just the radical part, not just the square root part, is going to be divided by 2 times the rectangle, so 2 times a. So without all of this, it goes x equals opposite b plus or minus square root b squared minus 4ac all over 2a. Now, if you're going to be in my class, I'm going to make you write this down like 5 times or 10 times to make you memorize it. So, we're going to use this again when our equation is in standard form, but it's not factorable. So when you can't factor, you're a little sad, so you're going to sing yourself a little song, and now you get to hear the song. It goes to like Pop Goes the Weasel. So when you can't factor and you're sad, you sing yourself a song to cheer yourself up. And it goes x equals opposite b plus or minus square root b squared minus 4ac all over 2a. And now I sing that song and I'm going to cheer myself up. All right, so let's go ahead and get started. So the first problem, we already have an issue. We're in form and it equals 0. This is not. So what I'm going to have to do is get rid of this and move it over here. So one person asked me, well, when you move the negative 2, why don't you divide by negative 2? And the reason why is if you divide by negative 2, I need to have this side become 0. And anything divided by itself is 1. So you just made this side turn into 1, not 0. So to make this 0, what I'll do is I'll add 2, because negative 2 plus 2 is 0. And then I'll add 2 to this side, but since none of these are like terms, I'll just write it in standard form. So x squared minus 7x plus 2. You're going to notice the same thing happens on the third problem, so I'll get rid of the 1 by subtracting 1 here, and that makes it equal 0. And then I'll subtract 1 on this side and just make sure I write it in standard form. So 2x squared plus 4x minus 1. And now we're going to do the quadratic formula. So in order to do that, I need to identify the values for a and b and c. And so a is the number in front of x squared, so that is technically a 1. B is the number in front of x, and you do have to see that as a negative 7. And c is the constant at the end. And now to find my two answers. Remember, we're always going to have two answers. Here's the squared. It's going to go x equals opposite of b. So where you see -7, I'm going to write 7 plus or minus a square root. And now we're going to take b and square it. And this is one I would suggest you just do it in your head and you get it on paper right away. So what's -7 squared? So what's -7 times -7? Remember, when you square a number, it's always positive. So you're going to get a 49. And then minus 4 times a, which is 1, times c, which is 2. And then all of that's going to be over 2a. So 2 times a. So I'm just going to get that in my head and write it down. So 2 times 1 is 2. From there, we got to start cleaning it up. And this is why the quadratic formula is not that great, because the cleaning it up is where we run into the issues. So the first thing you should always bring your attention to is inside the radical. We don't want all of this. We just want one number. So when you have to choose between subtraction and multiplication, you should do your multiplication first. So 4 times 1 times 2 is 8. So all of this is worth an 8. And now I'll have 49 take away 8. And when you have 49 take away 8, then in that radical, in that check mark, you're left with the 41. And then you put it over 2. So again, this is x equals all of this. And there are two answers. One answer is 7 plus the square root of 41 divided by 2. And then the other answer is 7 minus the square root of 41 divided by 2. And remember, the square root of 41, that's about 6, because it's in between the square root of 36 and the square root of 49. Like here. So it's about 6 something. So I'm having 7 plus about 6 divided by 2, and then 7 minus my 6-ish number divided by 2. So one thing that I want to bring up is, although this is a good answer, one of your goals in this chapter is when you get to the radical, if this number is not perfect, see if there are any factors that are perfect, just like we saw in that previous video. And for 41, remember, we will not choose 1, so 41, nothing about it is perfect, so this is actually going to stay as our two answers. So when we're done, this is what equals x. All right, let's go to our next problem. So this is in standard form. So before I do anything else, I'm just going to identify my a, b, and c. All right, and let me back up. What I really should try to do is factor it. So if I did try to factor this, I would be looking for factors of 1 that get me to 5. And there are no factors of 1 that can make 5. So because this is not factorable, you're sad, and now you're going to cheer yourself up with your song. And the same would have happened here. Had I tried to factor it, and that's what I should have started with, factors of 2 that get to -7, there are no factors of 2 to get to -7. So again, it's not factorable, so you're sad, and we sang our little song to cheer ourselves up. All right, so let's go ahead and identify a, b, and c. So a is this invisible 1, b is 5, and c is 1. So what I'm going to do is now sing my song. X equals opposite b, so that's -5 plus or minus square root b squared. So I'm going to go ahead and take 5 and square it. So 5 times 5 is 25, minus 4 times a times c. And then all of this is over 2 times a. And so again, like before, I'm just going to go ahead and do 2 times 1 and put 2 in here. So again, the first place you go is your radical. And you do the multiplying first. Multiplying goes before subtraction. So if I take 4 times 1 times 1, that's 4. And then 25 take away 4 is 21. And this is a great answer, but let's just see. 21's not perfect. It's not in my list, but maybe there are factors of 21 that are perfect. So I go here and I just double check, and since we won't be using 1 and 21, 3 and 7, none of those parts are perfect, so I have my two answers. One answer, and I'm actually going to write them separate, is -5 plus the square root of 21 over 2. Whoops, I did not mean to put both those in there. Give me one moment. I just meant to put plus, and then -5 subtracting the square root of 21 over 2. And those are my two answers. Now, what is the square root of 21? It's around 4 something, okay? So this is negative 5 plus my 4 number, and then when I get that, I would divide it by 2, where this is negative 5 minus about 4 something divided by 2. So two answers, and they both equal x. Now, typically, we wouldn't write them twice. We would just write them once like that, but you do whatever works for you. All right, so again, let me show you why we are going to use the quadratic formula, because what I want to try to do is factor it. Factoring it is so much faster than the quadratic formula. So I need factors of negative 2 that get me to 4, and you will see that that is not factorable. So now I'll use my quadratic formula, where a is 2, b is 4, and c is negative 1. And so that's another nice reason for standard form, is because a, b, and c will just be right in order. So now it goes x equals opposite of b, so negative 4 plus or minus, make a bigger square root, then I'm going to take b and square it, so 4 squared is 4 times 4, I'm going to go ahead and make it 16, minus 4 times my a times my c, and then all of this is over 2 times a. So now 2 times 2, I'm going to do that in my head, and I get 4. So just like before, go straight to your radical and do your multiplying. So 4 times 2 times negative 1 is a negative 8. And remember, when you subtract a negative, you're going to bring those together, and it's going to make a positive. So this is actually going to be 16 plus 8, which is 24. So moving down, inside that radical, that check mark, it's 24. And although this is a great answer, but 24 is not perfect, maybe there are parts that are, so I look at 24. And when I look, I notice 4. 4 is a perfect number. So here, I'm going to simplify this. So this is a good answer. We're just going to make it better. So I can break this up into the square root of 4 and the square root of 6. And now what I'll do is I'll take the negative 4 plus or minus over 4. None of that changes, but now the square root of 4 is this 2 along with the square root of 6. And so this was a good answer. This is a better answer, and that looks like a negative 6. That is a positive 6. Let's see if we can fix that. All right. And this is a great answer, but there's one more thing you can do, and I call this the simplifying triangle. I'm going to make a triangle between these numbers. The radical does not get to be part of the triangle. And I'm going to look, is there something I can factor out of all of these? Is there a number that divides into all of these? And that, there is a 2. So what I'm going to do is divide this number by 2, and I get negative 2. Here's my plus or minus. I'm going to divide this by 2 and get a 1. This is left untouched. You just leave it as the square root of 6. And then I'm going to go here and divide this by 2, and I get 2. So good answer, better answer, best answer. Your goal is to get to here. And so if you mess up along the way, don't worry about it, but this is your goal to get to here. So that's why I'm going to circle this one. All right, let's take a look at this one. So again, the first thing I am going to try to do, because it is factor, because it's in standard form, is I will try to factor it, and it's in standard form equaling 0. So I need factors of 3 that make negative 4. So right now I can do 1 and 3. But the only way to get to negative 4 is if these were both negative, and when these are both negative, that actually makes a positive 3, so this is not factorable. Very close, but not quite. So I'm going to make my a, which is 1, b you should see as negative 4, and c you should see as negative 3. And now I'm going to sing my song to solve for x. So x equals opposite of b, so I'll put 4 plus or minus square root. I'm going to take b and square it, so negative 4 times negative 4 is 16, minus 4 times a times c, and then all of this is over 2 times a. So I'm going to go ahead and just do 2 times 1 in my head. So coming down here, I'm going to go to my radical, start with the multiplication, so 4 times 1 times negative 3 is a negative 12, and again, you're subtracting that negative. So when you put those together, that's just like adding 12. So it's going to be 16 plus 12. So in that check mark, I'm going to get a 28 because 16 plus 12 is 28 over 2. So good answer. Let's go for a better answer. So I'm going to look at 28, and maybe there are parts of 28 that are perfect, and as it turns out, 4 and 7, 4 is perfect. So I'm going to break this down into square root of 4 and square root of 7. And then here's the 4, here's the plus or minus over 2. The square root of 4 becomes a 2 with the square root of 7, so good answer, better answer. But now I'm going to see if I can do that factoring triangle. Remember, your radical does not get to be a part of it. And when I make this triangle, I can take a 2. I can factor a 2 out all of those. So the best answer, divide this by 2, you get 2. Divide this by 2, you get 1. This is left untouched. Divide this by 2, and you get 1. So there are my 2 answers. So again, good, better, best. Okay? All right, and I think that is about it. So now you're going to try the practice. This is one where you should definitely check your answers when you're done and look for the good, the better, and the best answer. That won't always happen. Sometimes, just like the first few examples, we got an answer and we couldn't do anything with it. So it was the best answer from the very beginning. And that is it.